Hi, this is Sandeep. Our project title is Symmetric Protected Topology Facing Classification Using Hybrid Quantum Convolutional Neural Networks with 3 quantum filters. Our guide is Arun Pandyan sir. Our teammates are Dattatreya and Nagasayani. These are our agendas. Abstract. In our project, a hybrid quantum collision neural networks was proposed for a symmetric product topology, phase data classification. The TensorFlow quantum packages are usually adding into the outcome of the quantum circuits for the layer of efforts of the classification of different numbers of the quantum filters we are using into the HQCNN model and testing. The different number of quantum filters we using in the HQCNN model design their performance of the HQCNN model of the different number of quantum filters by comparing the validity of testing performance. The simulation results showing that the classification acquiring in the provided of HQNN 4 quantum filters. These are the aim of the project to develop a quantum data using a project quantum collision futures for image dataset. The design a novel hybrid classification techniques using a quantum circuits and collision neural networks for image classification to analyze the performance of a hybrid QCNN networks and classification CNN networks on image classification. Scope of the project: developing a neural hybrid classification techniques using a quantum circuits and collision neural networks for image classification a quantum data. Identify the importance of the quantum filters, number of classifications models or design. These are the introduction. Quantum computing is a recent computing technique inspired a quantum physics to solve the computing problems using a quantum states and products such as a surprised to the interfacing and artificial intelligence neural networks are powerful techniques to solve the model design making the challenges. Should also classify the time service force forecasting and neural languages processing. Also advanced the neural networks like collision neural network CNN and RNN needed a more powerful tool to traditional computing system to handling the complex data. This is also introduction. Multiple number of quantum filters can use it to the conducted a quantum states in a HQCNN model for the future enhancement. The number of the quantum filters of they have HQNN model by the occupying basing on the dataset and the architecture of the model. Two combinations of the recent artificial neural networks and quantum computing techniques by extended the design making to the capabilities of a modern computing. Quantum computer is usually a survival forces application of the quantum computing in a neural networks developed for the quantum testing. The significance of a quantum inspired to develop the collision neural networks of a image classification takes a studies using by the dataset in 7 and 3. The another definite to the QCNN achievement better performance to the traditional CNN model of image classification application. In 9, the author proposed the quantum matched filters techniques and deep speaking neural network suggestions are the scanning images. The quantum matching filters techniques improved the performance of the tasks to achieve a average accuracy of 98.21 present on the test data. By using the quantum generic technology for the creating a space of matrix to the applying the improved the performance of the hyper-spectral data classification. These are our modules. First module we using to the installing of the TensorFlow 2.7.8. We installing the directly these packages on Google Colab. This is our second module, step 2. Input installing the TensorFlow Quantum. This package is also directly in Google. We are installing the import the package resources. Module 2, design the quantum classifier with multiple PQC filters. This is the model. We insert the input and add the circuits and PQC filters we added by 4. The downs we came to the output. This is module 3. After we completing this PQC filter classification, we compare to the process of HQCNN with various new number of the filters. This is the main output of the project. This is the standards and policies. Python standards use ISO IEC YTR 24724. This is our standards and policies.
Implementation. In this implementation, using architecture diagram, data flow diagram, ER diagram, sequence diagram, collaboration diagram. Architecture. The HQCN model was extended with 4 parallel connected quantum filters. The model was named HQCN 4Q. The outputs of our 4 parallel connected quantum filters are combined using a concatenation layer. Data flow diagram. In this data flow diagram was collected and the data will be go to pre-processing model for the SPT data preparation. ER diagram. All the models like SPT data preparation and convolutional data for data circuit PQC performance computations and process the data enter result analysis and to be get the output. Sequence diagram. The sequence diagram is a unified modeling language diagram that utilizes the sequence of messages between objects in an interaction, and processing the system need to produce analysis the output and generate an output in graphical representation. Collaboration diagram. A collaboration diagram, also known as combination diagram, is an illustration of the relationships and interactions among the software objects in the unified modeling language. Testing. Unit testing. Testing is that the method of evaluating a system is that they intend to seek out whether or not it satisfies the described needs or not. It is the strategy of effective software with the intent of graduating in that the code meets its requirements associated with the grid using expectations and does not fail in an unexpected manner. Integration test. Integration testing is a methodological for building the software architecture while also running tests to detect faults related to the interference. For the described product, a sequential analysis of interactions testing was undertaken. Test results. These are the test results of our project. Input and output. In this input, we using a different quantum filters like PQC filters. And PQC filters, we got a HQCCN. In a HQCN accuracy and HQCN loss are the quantum state. Conclusion. A deep conclusion neural network is a part of deep neural networks commonly used to classify the multi-data such as images and audios. And a quantum computing technique provides high computing power with low energy combination. It is the best alternative to traditional computing techniques to perform complex tasks. Future, future announcement to develop a quantum data using predicted quantum kernel features from image data to design a novel hybrid classification using quantum circuits and convolutional neural network for image classification. Developing a novel hybrid classification using quantum and convolutional neural network for image classification on quantum data. References. Um, these are the references. We take 14 references for referred in literature papers. These are references. And this is a plagiarism report of PPT. This is post presentation. In this project we published IEEE. This is our team members certificate. Thank you.
By using the installing of the TensorFlow here. After installing the TensorFlow, the code was taken by the one capture image. This capture image only find with the quantum computing. Quantum computing is a type of the using quantum machines or performing computing classify computer process data for the 0 and 1, but in the case of the quantum computing the 0 and 1 of is expected. It can store a process data is a qubit can process data in 0 1 or 1 0 1 0. This information both are true or false. We are using a quantum computer because in normal computer doesn't give the actual output in so many ways is there, but the quantum computing we can find the certain quantum state. That's why you using this quantum computer. Here in quantum computing, recent computer techniques inspire the quantum physics to solve the computing problems using a quantum state properties such as a artificial neural networks. Powerful techniques to solve the modern designs, making into the challenges of the classification. Uh, the integrated quantum states, the collision neural networks is named by the hybrid quantum neural networks. Hybrid quantum neural networks. Uh, after we run this code, we got this graph. This is a training a quantum CNN, the direct excited crystal state. We separated the states. This is the PQ first state, PQ1. We given the PQ1 a filter here. We got a HQCNN 1QF accuracy and HQCNN 1QF loss. Up to we do this PQC layers 5. This is second layer, this is third layer, this is fourth layer, this is fifth layer. Up to this we do these layers. After we getting HQCNN 5QF loss and HQCNN 5QF accuracy, in this model multiple number of quantum filters can be connected to the quantum states, and HQCNN model is for the future extended process. The number of quantum filters is HQCNN model should be as occupied based on the dataset and architecture of the models. So this is the architecture of the model. Collision neural networks are recurrent neural networks needed to the powerful computation tool. The traditional computer systems to handle the complex data. That's where we're using this complex the artificial neural networks and quantum computing techniques may be expected to the decision making a possibilities of a modern computer. Nowadays, this quantum computer presently we use only a starting stage. Now, in upcoming days, we use the quantum computing is in normally. This is the final output. After we completing the 5 filterizations, we got this output: hybrid quantum CNN performance. We can see this here. We got a HQCNN1, HQCNN2, HQCNN3, and HQCNN4 and HQCNN5, and we got hybrid quantum CNN performance on this validation loss also. Validation loss we got a five layers. We see this graph. This is the main output of the project.